Iuka is one of the strongest, most advanced PRD mills in the country. This plant is 50% more powerful than previous PRD mills, rolling pipe up to 120-inch outer diameter with a 1-inch wall thickness. The facility currently employs 40 highly skilled metal trade workers and looks to expand to 100 workers in 12 months as they produce spiral welded steel pipe used primarily in heavy construction such as buildings, bridges, and wharves. Join us now for a short tour of our facilities.
All right, this is our coil storage area. We receive coil steel from the Yellow Creek port via barge and rail and truck. Truck delivers directly here. We've got 3 spiral weld mills, spiral weld pipe mills in the plant. This first mill here is our smallest mill. It'll run pipe from 16-inch diameter up to 36-inch diameter, half-inch wall thickness. The mill in the middle there will run pipe from 24-inch diameter up to about 10-foot diameter, 9-foot diameter, up to 3/4-inch wall thickness. The big mill on the end there is our new mill. Will run pipe up to 10 feet in diameter, 1-inch wall thickness. That's the biggest anybody can run in the country. And we just recently completed an order of 6-foot diameter pipe with 1-inch wall thickness. And the wall thickness is the big factor there. You know, there's several people that can run 8, 9, 10-foot pipe, but not in 1-inch diameter. And that's what we're able to do with this mill. The start of the process, we take a coil of steel, put it on our coil reel, and the drive rolls will pull the sheet through, and we have a milling head on each side of the sheet that mills off some of the strip, makes the strip consistent, puts a bevel on each end of the pipe. These are the milling heads. Let me show you what the end of a sheet that just comes in from the steel mill. Actually, that's a pretty good edge, but it's called a mill edge. It comes in straight. It comes straight from the mill like that. We will take it, at least on this machine and that machine, run it through a set of milling heads, and it mills it down to where the sheet is exactly the same width, because it does vary coming from the mill. And also it puts a bevel on either side of the strip that makes it easier to weld. Blades here get dull and you have to take them out and turn them. And so we have an extra set, so when we pull those out, we just put the new ones in, swap them out. You can see how it rolls around. The strip rolls around, and we've got a welder, a submerged arc welder inside the pipe, and then there's one downstream here on the outside of the pipe. So we're putting 2 welds on it, and it's a submerged arc process, meaning that the arc is submerged in a pool of flux. So it's a very clean, quiet welding process. You can stand right in front of it, you can look at it, you can watch it without worrying about burning your eyes. And it gets very good deposition and fusion on real thick metal. Here's a good shot of the end of the pipe here. This is a good shot of the weld. You can see the submerged arc weld gives you a nice, smooth, consistent weld. This particular material is 1/2-inch wall thickness. This apparatus is our plasma cutoff. It cuts the pipe to length. When the pipe gets to the right length, it'll engage the pipe and follow it along as the pipe's turning and cut it. It'll roll off on these racks here. This machine works the same way the other one we just looked at works, except it on a bigger, grander scale. It just has a much larger capacity. Again, this machine will run up to 10-foot diameter pipe with 1-inch wall thickness. What we're currently running is a 30-inch pipe, which is the smallest pipe we've ever ran on this mill, at a 3/4-inch wall thickness. So it's a lot of stress and strain to bend a strip 3/4 inches thick into a 30-inch pipe. But this machine gives us the capacity to do that. Okay, this is the control panel for the PRD mill. The welder controls and the seam roll controls are on this panel. You have an operator up here that basically controls the operation of the mill and the direction of the pipe. You got a camera on the ID welder and a camera on the OD welder, and the position of the weld is controlled with this joystick. You line up the crosshairs on the center of the weld, and that directs the welding. This pipe that we just rolled in is a 72-inch OD pipe, 1-inch wall thickness. We just ran for the California Department of Transportation. It's going to ship via rail to Monterey County in California for a bridge project. These pipe for the California Department of Transportation have a 30-degree bevel, so they will actually drive these pipe into the ground, and they'll take another one just like it. These are 80 feet long, and they'll weld another one onto this one in the field and drive it down in the ground. So that's what the bevel's for. We can run pipe up to about 120 feet long. Any diameter up to 10 feet. That is that's our Taylor forklift, 80,000 pound capacity. We have another Pettibone lift, which is right across there. It's 40,000 pound capacity. This is a 78-inch pipe, 5/8 wall thickness that we're going to take down to the Yellow Creek port and put on a barge. That pipe there is about 25,000 pounds, 13 tons. On some of our pipe, larger OD, thinner wall thickness like 5/8 wall, the pipe will actually collapse on its own weight somewhat, and especially if there's going to be pipe stacked on top of it, such as the case of this barge, we'll put cross bracing in it to keep it from collapsing.